On to our next set of questions, and things are beginning to become more difficult now. Question 11 looks very familiar, but isn't in reality. AB, CD, and PQ are straight lines. All angles are in degrees. Show that AB is parallel to CD. So when I see this diagram, I'm immediately thinking, oh, well, I could be solving this, and I know that this angle here, this 9x subtract 7, will be equal to my 7x add 23, because they're corresponding. But actually I don't know that, because I don't know CD and AB are parallel. So how will I show that AB is parallel to CD? Well, to be parallel is to have the same direction, and to be parallel is to follow the parallel line properties. So if AB is parallel to CD, then it will be the case that 9x subtract 7 is equal to 7x add 23. And I'll just make a note of that at the bottom. That's what I want to show in the end. Sorry, my pen appears to be running out of ink. I'll get another one. So I'm looking to show that 9x subtract 7 is equal to 7x add 23. There you go. 9x subtract 7 equals 7x add 23. That will show they're parallel because they'd be corresponding. So that's just my notes to myself. But I need to find what x is first in order to be able to do that. So I look on my diagram for something that will let me do so. Because I know that AB is a straight line, I know that this angle here, 7x plus 23 add 3x plus 7, must be equal to 180. That's because my angles on a straight line add up to 180 degrees. The mark scheme for this doesn't actually require that you give reasons, but I think it's sensible that we do so. So I can solve for x in here. So I have 10x and then add 30 is equal to 180. Subtracting 30, 10x is 150, divided by 10x is equal to 15. Now we can all do that, even if we don't know how we'll show AB is parallel to CD, and that will pick us up a few marks. Then what I'm going to do, using my note down here, so I can cross it out, is I'm going to work out 9x subtract 7, which is equal to 9 times 15. Well, 10 times 15 is 130, subtract 15 is 135. So 135 subtract 7, which is 128 degrees. Equally, 7x add 23, I can work out. 7 times 15, well, 7 times 10 is 70, and then 5 times 7 is 35. So that's 105 degrees. Add 23 gives me 128 degrees. So I have found that corresponding angles are equal. Therefore, CD is parallel to AB. And it is important that we have that conclusion at the end. It says show that, but it's important you show, like, because they're the same and they're corresponding angles, it must therefore be CD is parallel to AB. You must have that conclusion for your final mark. Question 12, evaluate 27 to the power of negative 2/3. Lots of ways you can go about doing this. I know that my negative means to take the reciprocal of my result. I know that 2 means to square my number, and I know that 3, or the 1 over 3, the 1/3, means to take the cube root of my result. Nearly always it will be easiest to deal with the denominator first, because the cube root of 27, I know, is 3, and this becomes 3 to the power of negative 2. Then I can do the squaring, so 3 squared is 9, so I have 9 to the power of negative 1, and then I take the reciprocal 1/9. You can do this in other orders. I wouldn't want to square 27, but I could certainly take my reciprocal first, so say 1 over 27 to the 2/3. Then I could cube root that, so 1 over 3 squared, and then 1 over 9, giving me the same result. And again, good way in the exam, give myself peace of mind that I've done the right thing. Question 13. Express x squared, add 16x, add 40 in the form x plus p all squared, add q. Completing the square form is what we call that, where p and q are integers, so whole numbers. You must show all of your working. Everyone seems to hate completing the square, but actually it's a fairly straightforward process, particularly where our coefficient of x squared is just 1. So what I'm doing, I have x squared plus 16x plus 40. I don't worry about the plus 40 just yet. What I'm trying to do is write some expression in terms of x add something squared, and then some constant afterwards that is the same as x squared add 16x. The only way that will work is if I have x plus 8 all squared, because that will give me x times x squared, plus 8x plus 8x plus 16x, and then I get my plus 64, which I don't want. But crucially, I've been able to write something that gives me my x squared and my plus 16x. And if I subtract 64, then I have x squared plus 16x, add 64, subtract 64, I have x squared add 16x. I haven't done anything with my plus 40, so that must stay there. And I'm basically done. I'll just need to simplify a little bit. A good trick for checking in the exam that you're doing the right thing is it will always be true that this number inside your brackets, p in this case, is going to be half of your coefficient of x. And then this number you're subtracting, and it will always be subtracting, this number you're subtracting will be the square of that p value. Then I just need to simplify, so I have x plus 8 all squared, subtract 64 and add 40, so subtract 24 in total, giving me my final result. If there'd been a coefficient in front of the x squared, everything would be the same. You just take out a factor of that coefficient at the beginning and then multiply by it towards the end. And that's in the next 3 set of questions sorted.